Just one moment. Okay. Can you see my screen? Adam, can you see my screen? Okay. Okay. So I think we can start. So welcome to our first online meetup. Because of coronavirus, so we moved to online meetups. And before we start, I have a couple of announcements, short announcements. First of all, this is kind of test for us. So we're testing tools. In this meetup, we're using Zoom for those of you who RSVP'd to the announcement to our meetup. And additionally, it's being recorded right now, and it's being streamed to YouTube Live on Cloud Native and Kubernetes Poland channel. And so if you have any other tools that are better, just contact us. And if there's anything wrong with this setup, please also let us know, because we want to make it better for you guys, so you can enjoy these online meetups. So the second thing is I've attached a poll to this Zoom. So for those of you who are using Zoom right now, there are 2 questions only. So we want to know whether this time is good for you, because it's unusual for meetups, and how long should they last? Because well, today we have only 1 speaker, but maybe for online meetups, you would also want to spend more time with us, like with 2 or 3 speakers. So please let us know. There are also these questions are also available on the Meetup page. I will send a link to them after Meetup in a separate mail message. So I think that's it. And the last thing for me is I'm not sure about you guys, but I'm pretty bored. So and maybe we could use this time to spend on like some kind of online workshops. I was thinking about a 3 to 4 hour event that is focused on Kubernetes technology or cloud native tools and so on. So if you have any ideas or on maybe what would you like to learn, so just also contact us. Maybe you would like to participate as a host of this online workshop. So also, please contact us on Slack, Cloud Native, and also on Kubernetes official Slack, or on Meetup, or send us email, whatever. So that's it from me. I think that Piotr would like to also say something. Just unmute. I will unmute you, Piotr. Are you? Yeah, you're
okay.
Right.
I think you can hear me.
Yeah.
So a very short message from my side. So we are still working on the Cloud Native Warsaw conference. I know that the risk is high. We will have to move the conference for the next year, or maybe even cancel it. But yeah, it's like for now we are still optimistic, and 9 and 10th of September we are still planning to organize the event. So that's basically all. CFP first round is almost finished. We are going to publish agenda in the next couple of days. So if you are still interested in Cloud Native Warsaw conference, we are still in the game, and we really hope it will happen this September after all these coronavirus issues are solved. That would be all from my side, and I think we can jump to
So without further ado, let's welcome Adam, and who will be talking about some interesting stuff regarding dosing your Kubernetes cluster. So Adam, you have the floor.
Okay, I'll just a standard check. If you can hear me, just show me. Okay, great. Yeah, so let me just start by sharing my screen. To desktop, okay. Unfortunately, while I'm sharing my screen, I won't be able to see the chat. So if there are any question pop up during this presentation, I will answer them at the end. Or maybe Tomek, you or Piotr can just ping if there are any questions which are appearing during this presentation. Okay. Yeah, so today's topic is dosing our own cluster, and also I will try to explain why our resource quotas are important. But before we jump into the main topic, let me introduce myself with one short slide. So my name is Adam Otto. I'm working as cloud native engineer at Container Solution. I joined the company in November 2018. I have 6 years of professional experience behind me. I was working as system administrator, network administrator, developer, DevOps, or whatever else you can think about. I probably did it in the past. I have been working with Kubernetes from version 1.2, which dates back to 2016, if I recall correctly. Also, I'm a big enthusiast of any cloud native technologies and whatever links to this space. So here is an agenda for today's short presentation, because just to make it clear, this presentation is more like lightning talk, and I hope at the end of this it will spark some space for the discussion, so we can share ideas and stuff. So in this presentation, first of all, I will share the bug in the Kubernetes control plane, which can actually cause a denial of service for your control plane. So in the introduction, I will tell more about this. Next, I will do a short demo. I will present in the real time actually how this bug looks like, what's happening in the cluster, and what consequences we can expect for this. Later on, I will go into the internals of the Kubernetes. I will explain where does this bug comes from. And finally go into the prevention. How can we prevent this bug from occurring, from happening? What mechanism does Kubernetes has in order to save us from breaking our control plane? Finally, I will go through. I will go to the managed Kubernetes clusters and share my research in order to see if they actually are like having any mechanism which will prevent this denial of service from occurring. And we'll end up by a short slide with some final thoughts. So yeah, what's the issue? So there's a bug in kube controller manager, and to be more precise, this is like replica set controller, which is part of the kube controller manager, which has this bug. So this bug consists, the behavior of this bug is that if your pod is assigned to the node but ends up in the failed state, kube controller manager will continuously spawn new pods. And these pods, the newly spawned pods, are spawned at the full speed. So for example, if our deployment has like, let's say 8 replicas specified in the manifest, it will spawn 8 pods per second into the control plane. So we can imagine that if the number of the replicas is quite significant, the impact and the stress made on the API server may be quite important. And the issue was first reported in the January 2019. And there are already few issues in the GitHub present for relating to this bug. Fortunately, it's still no fixed, but as far as I know, there are some discussion going on in those tickets, what is the best way to fix this. So we know what's the bug, what can it cause, but how to trigger this. So you may be wondering, for example, if any end user can trigger this. And the short answer is yes, any user with the right to create deployments in the cluster can trigger this bug. So I managed to identify like 2 ways of triggering this. So the important thing is that in order to trigger this, the pod must end up in the failed state. So as I mentioned, I managed to figure out 2 ways to trigger to make pod in the failed state. So the first one is by scheduling pod directly to the node and skipping the scheduler. And in the definition of the deployment and the pod in the deployment, because when I mean pod, I mean the pod template spec in the deployment. So the first is by scheduling pod directly to the node with CPU limit value higher than CPU count of the node. Another way of triggering this is by using the unsupported options in the kubelet. So for example, if we haven't enabled the sysctl support in the kubelet, the pods which are going to be scheduled on the node, all of the pods will end up in the failed state. So we can trigger this as easy as just setting up a security context and adding some option for the sysctl. And we have an example here. Yeah, so just configuring the sysctl, it will trigger this. But let's see what does it do in action actually. So in the presentation there is a video, but I will try to do it like real time, so I can explain real time and we can see actually what's happening to the cluster. So I have here a Kubernetes cluster which is running the most recent version. It's running on the background, and it's running version 1.17.4, which was released like last month or something. I have 3 nodes here. And of course, the setup of this cluster is just for the proof of concept and for showing the bug and the behavior and the consequences, what can happen. Because right now I have only like 1 instance of etcd, 1 instance of API server, and control manager and scheduler. So of course, this kind of setup you won't find in any production system, but this is just to give you an idea what can happen. So let me just show you also the control plane, just to make sure everything is in place. So I'm using a Canal with Calico. So this is like Flannel for a network overlay and Calico for network policing. Standard setup, which we can obtain from Kubeadm. Now you can see core DNS, etcd in container, API server, all of those are in the containerized static pods. Okay, so let me go to the manifest, which will cause this wrongful behavior in the Kubernetes cluster. So let me just do. Okay, other way around. Let me just set a watch on the default namespace. So I prepared like 2 manifests, the malicious manifest, let's call it. So those are like simple BusyBox deployments with 8 replicas. And the thing which I did it, so I artificially created like those manifests are artificially super big. So this is only for the purpose of demo. So I can so the collapse of the control plane can happen quickly. In the real case scenario, you would require like thousands and thousands of pods in order to see any impact on the control plane. But just to show you that this is really dangerous, I created those artificially big manifests. So what I'm doing here in this example, I'm scheduling manually those pods to one of the nodes, and I'm also scheduling the limit for the CPU is actually higher than the CPU count on the node. So each of the nodes in the cluster has only 2 CPUs. So let me apply it. And as we can see now, the pods are being created continuously. Even though the number of replicas is 8, we can see that it's like increasing like crazy. So if I, for example, right now, if I go to the master node and to the directory which hosts etcd, I will be able to see how quickly it grows. So let me just maybe just to make it more explicit. So we are in the etcd directory. Let us observe. So maybe to speed this up, let me just check one more thing. Yeah, everything is going as expected. Yeah, we can see that it already grew by 60 megabytes. So let me just apply the other malicious manifest, which is busybox sysctl.yaml. It's very similar to the previous one. Also, we have like 8 replicas in here, but the thing is that we are not skipping scheduler, and we are using this security context. So my kubelets on each of the nodes, my kubelets are running like the default configuration. So by default, the kubelet does not allow the configuration of the sysctl. So let's see what happens now if I apply it to the cluster. Okay. You can see it's still growing. I wonder why I cannot see the sysctl forbidden. I know I can see because I did some changes yesterday. Of course, if you do some changes in the meantime, the demo always fails. So let me just explain why this one does not appear. Because yesterday I added some default resource quota to this cluster. So just to show you that default resource quota won't save you, but anyway. Yeah, so I don't specify the limits for this pod, so this is why it was not scheduled by. And let me just quickly add it to this. Of course, it's not requested resources. It should be supposed to be resources. Please correct me if I'm wrong this time. No final resource. Oh my god, I need to double check. Oh, actually, I don't have to double check. Let me just copy from the other guy. But in the meantime, we can see how the thing is growing. So let me just copy it. Okay, this should be good now. Just change it to 2, because maybe even 1. Make sure it's scheduled correctly. Yeah, so we can see now the new pods are being deployed, scheduled to the Kubernetes, and this time we haven't skipped the scheduler, because it's even scheduler assigned this to the node, and still we are seeing sysctl forbidden. Let's see what's happening in the logs of the kubectl of the controller. So So we can see that controller is being like spammed with the events from the cluster. So it will take, let's see, I think it will take around 2 more minutes. So in the meantime, let me explain where does this bug comes from. So let's see into the Kubernetes internals what's going on in this in the kube controller manager right now. In the kube controller manager, as I mentioned earlier, there's a subcontroller which is responsible for replica sets. So what this controller does, it is actually watching for events about replica sets from kube API server. So whenever it receives like an event from the API server that new replica set was created, it starts on creating new pods into the cluster and into the cluster, and then the scheduler takes over and kubelet finally. So they are scheduled onto the appropriate node and are safe and running. So in the code for the replica set controller, since it is controller, there's like a main control loop. So the main control loop is responsible for ensuring that the cluster is in desired state. So it means that all the configuration from replica sets are reflected into the cluster. So it means all the pods from replica sets are in the cluster. So in the replica set controller, we have this part of the code there where it's actually listing all the pods which are belonging to this replica set. Then it is filtering for the active pods from this from the pods belonging to this replica set. But in the method which is responsible for filter active pods, we may see that active pod is the one which is not in the succeeded phase or failed phase. So in our case, since all of the pods end up in the failed phase, since they are not even running, but they are not even operated by the Docker or other container engine. So they are all in the failed state. So what it means that the filter active pods, this list is empty. So this empty list is then passed through some intermediate processing, which we are not interested in now, but it goes into this method which is called manage replicas. So this manage replicas method is responsible actually for creating all the pods all the missing pods for the specific replica set. So since we are passing here like an empty list, the diff value here is always like negative, so it will be always creating pods independent. Well, whatever number of the pods is already in the cluster, this value is going to be always negative for this specific case. So it will be always like creating new pods. And since the control loop is like invoked every second, so this is why we are observing this weird behavior. So those pods are keep on getting created and deployed and scheduled into the cluster. So let's see what's the status. It's still like more. We have our etcd is already 2 point something gigabytes. So we need probably few more minutes before it goes into the broken state. Let's see how does everything is running still as expected. Okay, I think I saw first error which was showing the let's see how many pods do we have now. I guess it must be a lot since we are waiting so much, or maybe the control plane just collapsed and we missed this, which would be like no. Not sure if it's worth to wait for this. And I think I will just continue with the presentation. Just let me see how many pods do we have here. Almost 2,000, not bad. And it's like less than 10 minutes or something like this. So you can imagine that. Okay, we saw. So now we have like our cluster completely broke. We can see those messages about etcd database space exceeded. Oh my god, I'm so happy that it worked actually. And now we were disconnected from the kube controller manager since etcd probably restarted on this node on the node with the on the master node. Let me see what do we have here. We can see the kube scheduler and controller were restarted. What else? Flanner, no, it's not related to this, but yeah, we can see that our control plane was restarted and probably it won't be able to start up since etcd has space exceeded. So we need to manually fix it right now. So let me just confirm it. Or maybe not. We are still seeing the pods running, but this is just a matter of time before it goes fully bananas. So let me just continue with the presentation. So the question is, how can we prevent a controller manager from dosing our cluster? And the answer is as simple as resource quotas. So what is resource quotas? So resource quota is a built-in validating admission controller, which can be enabled as a flag to the API server. So it ensures that requested pods do not exceed enforced limits. So for example, if we specify in the pod definition that we want like 2 CPUs and resource quota says that the maximum allowed CPU is 1, it will like it will discard this request at the time when we communicate with the API server. So this is what the resource quotas are for. And what the typical resource quota looks like. So here we have 2 examples. The one on the left is the one taken from the GKA from Google. So we can see that this one is mostly focused on limiting the number of different resources in the Kubernetes, like ingresses, jobs, pods, services. And another one is about like limiting the number of CPUs and memory requested by the pods depending on their priority class. So the one from the right was taken from the official Kubernetes documentation. But the thing is that none of those 2 resource quotas won't save you from the presented behavior. And the thing is because the hard limit on pods that we can see here is only for running pods. And the pods which we were seeing were in the failed state. So they were not, the running state is not the same as failed state. So they were not going to be accounted for this resource quota. So in order to save this, so this is what I said about the running pods. And another problem is that if we don't have like a default, if we don't enforce like default values for the CPU or memory in the pod manifests, the resource quota won't take it into account. So we need some mechanism to enforce like default values. And for this, we are using another admission validating mechanism, which is limit ranges. So limit ranges, in the limit ranges, we can like specify that the default value of CPU or memory limit or request that should be assigned to the pod or container. So yeah, so this is what I just said. So if we want to avoid this weird behavior to have like a mechanism which will save us, we need to set hard limit on the objects in the etcd. So there's this instruction in the resource quota count So this count is directly related to the number of the objects in the etcd. And another thing that we need also always to be present in the cluster is the limit ranges with the default values, so we can easily so each of the pods has some default value for the CPU limits, and we don't rely on the users in that case. So we may be wondering, okay, this is nice. You have been running here a pretty nice 3 nodes cluster, but what about the managed Kubernetes services? So actually, I did some research in this space and tried to reproduce this behavior in each of the 3 big players, which is like GKA. So GKA Kubernetes cluster, they come with default resource quota. They have a bunch of managed pods which have set resource requests and limits. And there is no limit count on the etcd objects, and we don't have access to any logs from the control plane. So what happened there? So yeah, since most of the Kubernetes managed pods had like they were responsible for monitoring and logging from the cluster, each of those has been killed by out-of-memory killer. So this is something which was expected, because I mean, if they were like processing thousands and thousands of those pods, the memory utilization was quite high. So this is actually not bad, because we prefer like some reasonable action than no action at all. Another thing that happened there, but was like even worse than this, it was the timeout. So I assume we hit some number of the threshold there, and at this point, when we had like thousands of pods, the kubelets from nodes started to time out, and they couldn't connect to their API server, which ended up with our cluster being pretty much useless. So this is very bad. The next player was AKS. So in the AKS, there is no default resource quotas, and the managed pods are without requests and limits. And those managed pods are also mostly responsible for logging and monitoring. And similarly as for GCP, we don't have access to the logs from the control plane. So what happened there? So we had some sort of memory overcommitment, since there was no like limits on the memory for those managed pods. They started to utilize all the memory from the node, and since there was no limit, the out-of-memory killer didn't come into the game. So they were just there sitting, consuming all the memory, and at some point, Kubernetes started to evict them randomly between the nodes. So this is even, well, if you ask me, this is worse behavior than the one in the GCP, because here the pods are just randomly jumping between the nodes, and whatever the pod is scheduled under the new node, it still gets like its memory utilization is still very high. And so at some point it gets evicted and comes back to the previously scheduled node. So it's like endless loop here. So not very good. And the third player from the big trio is EKS from AWS. So there is no default resource quotas, but it is what was surprising. It is actually that it is possible to enable logs from the control plane, and the number of managed pods there is very minimal, and they are set with limits and requests. So it was surprising to me, but I haven't seen any impact on the Kubernetes control plane in the AWS. And it made me wonder at some point what their backend actually is, because I mean the number of pods which were scheduled there, like thousands and thousands, this is quite a significant number of the data in the etcd, and I haven't seen any impact. So I mean, I just wonder at what point it will collapse there. And yeah, so we could only see the log spam. So those are the same messages that we saw in the demo that I just presented. So those are the logs from the control manager. So we could think that we could use those for some sort of alerting based on the logs rate and stuff like this. So it may be very useful to set this kind of things in the AWS. Of course, in addition to setting up the resource quotas, but yeah. So here we are at the end of this presentation. So some final thoughts. It is important to have resource quotas in the cluster because otherwise it poses a huge risk for the whole control plane, and single user can by mistake bring down the whole control plane. And another thing to note is that managed Kubernetes services are not idiot-proof by default. This is something that you would expect from managed Kubernetes services, but it's not. And their impact varies by cloud providers. So the things that we as operational or cloud native engineers that we have to consider is whether it is worth to like separate critical workloads by clusters, or maybe to have like a critical, maybe it's worth to have like a backup cluster in the standby end. When the things are bad in one of the clusters, we could just smoothly connect our load balancer or whatever we are using to the new standby cluster and recover from there. Because the other thing which is worth to remember is that even though the control plane collapsed and is broken, is unusable anymore, the workloads are still operational. It is because the Docker takes care of it. And the real challenge, is actually to, once we fix it, our control plane, and we have it in the healthy condition, the real challenge is always actually to reconnect the kubelets and the nodes back to the control plane. Because together with the bug, which is noted here, there may be some like differences between what's on the nodes and what's in the etcd. So it may lead to some weird behaviors there. So yeah, definitely I would suggest to go for the backup cluster in those cases. So this is it from me. I would be glad to answer your questions, or maybe we can like discuss what do you think are the best options? How can we keep our clusters?
Sorry, Adam, you're just on mute by accident. I just muted you. Sorry. Can you unmute yourself?
Okay, yeah. So I was just saying that if you have any question, I will be more than happy to answer them. And also, if you have like other ideas, how can we prevent from a control plane from going down, or how can we ensure that our business is always operational on the Kubernetes clusters? I will be glad to like share I will be glad to hear your experience from this.
Excellent, excellent. Thank you, Adam. Before we start some Q&A session, I just want you to know that you guys can unmute yourself, because right now, if you have any questions, just unmute yourself and ask Adam directly, or you can also write on chat. So I guess Jarek, you raise your hand. Can you can unmute yourself if you want, or because I think that
I raised it some time ago.
Okay. Okay, so I have
no questions at this moment.
Okay. So I guess Piotr, you had some questions, but I guess they were answered by Adam already.
But I think that really good monitoring could prevent this kind of issues in production, right? So we should get notifications before something really serious happens, like thousands of pods being created with no reason. So that should be handled by properly configured monitoring. So we should get alerts 5-10 minutes in advance before each CD cluster is overfilled with fake data.
Yeah, so that to be honest, that was really scary for me, because regardless if you're using GCP, AWS or Azure, you're just, I don't know, you're screwed. And so I have a question to Adam, actually, because why haven't they fixed these bugs already? Because that's just scary. And
I mean, from What I read in the GitHub and the conversation, the problem is because those failed state is set by kubelet. So how do they let know the controller manager the kubelet failed to schedule those spots? So they need some backward loop, the backward feedback to the controller manager in order to do this. So they were like discussing this for a long time and there was no action. Recently, I saw that they are thinking mostly about implementing some sort of the back of time. So something similar as we have for for example, image pull back off. Yeah. So we every time the pod fails, it's the time that the next time it tries to do the same task again is postponed by some random amount of time, and it increases every iteration. So this is what they are actually thinking about implementing, but it's still like still in the conversation state.
So up till this point, all Kubernetes clusters are affected.
Yes. So this is, well, of course, if you don't set up properly your resource quota, you are only concerned. But from what I said, from what I read from the documentation, the default one, this is what I presented, won't save you from this bug.
Yeah. So default values. Okay. That's scary. That's scary, really. Okay, guys.
That's scary because because every developer having access to Kubernetes clusters, having access to CI/CD pipeline, right, is capable to destroy any cluster actually in component. The DevOps team, in most cases, doesn't have the capacity to review all the changes in the Helm charts, right? All the changes in the YAML files being deployed to the clusters. So in most cases, we have like 10, 20, 50 development teams and only one DevOps or infrastructure team. That is responsible for maintaining the infrastructure, maintaining Kubernetes clusters, and they don't have enough capacity to review every single chart. Taking it into account, I think it would be nice to have to build a tool scanning all these Helm and other YAML files for this kind of possible dangerous DOS produced by Adam. So kind of similar scanners like we have for Docker images today. We should be also scanning YAMLs for this kind of potential risks.
I wonder if you could not achieve this with, for example, OPA and specifying some sort of the policies that you cannot like specify node name in the deployments, or you cannot use sysctl in the security context, stuff like this. So this is something that needs to be investigated, because this way you can just hook OPA as an additional admission validating webhook into Kubernetes. So it will save you from all this kind of stuff.
Yeah, as long as you're aware of those solutions and
yeah, exactly.
you can actually apply them, because there are so many tools and some people probably will go with some default settings. And I'm surprised that AWS actually is resilient to this bug. Yeah, that's
they are resilient because they don't have much of the managed pods. So I don't have much experience with AWS, but I assume they expect you to implement your own monitoring and logging solution. So this is why I haven't seen any of those going like bananas. And another thing which wondered, because for AWS and for Azure, actually I haven't seen any of the impact on the performance of the API server. So I just wonder, what do they have in the backend for their Kubernetes clusters, and wonder if at some point it will actually explode even worse than in Google.
Yeah.
So not sure we can get those information from them.
Yeah, that's an excellent idea to test those providers against any other vulnerabilities and so on. Yeah, that's kind of
what is also quite interesting is if they share API servers between different Kubernetes clusters.
Yeah,
right? So,
I think
that could be the case, and that would make the issue even more interesting. So break clusters of other customers, right?
Yeah, because we don't know actually what the setup is. How many etcd servers are there and so on. Yeah, that's interesting.
So etcd is a good example. I'm pretty sure they share, etcd across many different Kubernetes clusters. So
yeah, so as a conclusion, so how to actually prevent yourself from dosing or from to fix this vulnerability, Adam? So you need to use resource quotas, and
the easiest way is to set up the resource quota.
And
but
that's
you
it?
must remember that you must set up the resource quota on the count of the objects in etcd. Because
okay.
if you use the hard limit on pods, it only limits the number of pods in the running state. So you need to make sure that this limit is set on the objects in etcd. So this is this count instruction.
Oh, that's interesting. Excellent. Will you share some of those slides somewhere?
Yeah. I will share in the meetup in the comment section.
Okay.
Yeah, and
Okay.
probably on the LinkedIn. So if
Yeah, great. Definitely, we have this meeting is being recorded right now as a part of YouTube Live. So probably we can also share your presentation. So I think if there are no other questions, I think
there's some question on YouTube.
there is a question. Okay. Have you seen any questions? Because I'm not sure.
So there's a question about if the resource quotas set at the namespace level, will it still break the cluster?
Well, in general, you set resource quota per namespace, so you must ensure that each of the namespaces has its own resource quota. This is what Google, for example, is doing. Google is setting up the default.
But your solution solution counting the number of objects in etcd in case of, for instance, serverless solutions like running open function as a service frameworks and so on, where you may expect thousands or millions of objects, right? And that wouldn't be the best way to go, because in these environments this is something normal. High number of pods or which serve for the functions, maybe as a typical workload. So I guess that in most cases that would be a solution, but not everywhere. Yeah.
Yeah, well, of course. But if you have like thousands and thousands, if you expect this kind of traffic and those kind of amounts of the objects, then you scale your etcd properly, and then you can set up like a higher value there.
Or if you start selling, coronavirus vaccine through your web store, you can also expect quite a lot of pods.
Okay.
Being deployed in a very short period of time. Yeah. Okay.
Thank you. So thank you, guys. I guess we'll see each other hopefully in a couple of weeks. So so don't forget about the poll that is attached to this Zoom. Those of you who are on Zoom, and for the rest of you, I will send a separate email. So thank you, guys, and see you another time. Bye.
Thanks.